How to 3D print from concept to finished product. Rather than showing you what buttons to press, I'd rather you learn what's going on when you 3D print. So get ready for a lot of lingo that I'm going to go over, but when I use unfamiliar words, I'm going to explain it in simpler terms. So what is 3D printing really? You at this point know what 2D printing is, and 3D printing is very similar. If someone were to email you a picture of the Mona Lisa, you yourself couldn't paint the Mona Lisa, but you could very well press print to send it to the 2D printer. Now, it's not too far off. If someone were to send you a 3D file that you couldn't create, such as this hand here, it would be very easy for you to actually press print and send it to the printer. So, what is it really? It's taking plastic and layering it one layer on top of another, much like stacking Legos. The technical term is called additive layering manufacturing. So here is a very quick little video here of Yoda being printed to show you what it looks like fast forward. Now, prints print much slower than this, but you see how it's adding it layer by layer. So I want to go over how there are some similar forms of manufacturing, such as the injection molding and milling. So to compare injection molding versus 3D printing, injection molding, you have a mold and you shoot all the plastic in just in one go, and you wait for it to cool down, and you separate the mold. And this is good for mass production of the same part, whereas 3D printing is good for making very specific one-time only parts. So if you were making a robot with 100 different parts, it's much better to use 3D printing. But if you were to print 100 of the same robot, and you need like a specific part, then it's better to just injection mold 100 of the same part. Now, 3D printing versus milling. Milling is actually quite opposite of 3D printing. You got a block of material, and you have a drill bit, and you mill away the material, unlike 3D printing. Now, milling is faster when you have a much bigger part, and you only need not too much material taken off of it. But 3D printing, you can actually make hollow. So there's pros and cons for using the different forms of manufacturing. So 3D printers come in all sorts of shapes and sizes, and home or consumer 3D printers have really caught on in the last couple of years. But I want you to know that there are also consumer 3D printers that are much bigger. They can print faster. They can print much more high quality prints, and with many other materials that a home 3D printer might not be able to 3D print with. Now, how do they really work? So the really common ones use a thing called stepper motors. Very self-explanatory. The simplest way to how these things work is they take steps. So if it takes 2 degrees per step and you want to go 10 degrees, you would just take 5 steps. Now, rather than going into great detail about how these things work, just admire just what it looks like on the inside of the stepper motor. And you notice that there's 4 here because most of the 3D printers have an X, Y, and Z axis, and a fourth one to move the material through to be put out. So here's the example of what it would look like. You would have the stepper motor right here, right next to your plastic, and this spins around, and the plastic goes through the nozzle of the extruder. This little part gets, can go anywhere. It gets hundreds of degrees hot, and it gets the plastic to a liquid state, and then when it pushes down, the nozzle right here squeezes the liquid, and it immediately starts to cool when it leaves the extruder. So here's the ones I'm used to at Broward College, the Ultimaker 2 Extended, and here are where the stepper motors are located. Now, some 3D printers might have the extruder move up and down, while some have the build plate where you print off of, go up and down. So this one right here, the extruder moves across the XY axis, but it's very easy that some 3D printers might have this print bed move forward or backward, depending on where your stepper motors are. And the fourth stepper motor is right here, and you see how this is a spool of filament right here, and you get quite a lot of plastic per spool. Let's see what else we have. So here's like a quick video I show people about how it has to heat up at first, the extruder, and then this particular 3D printer has two. Let me pause. Has two fans. So even though the plastic starts to cool down as soon as it leaves the extruder, these two fans right here blow air to help it cool much faster. And another added benefit of the particular 3D printer right here is this actually has a heated print bed, so it keeps the plastic adhesed to the bottom. Because some printers don't have heated print beds, you'd have to use a lot of glue and tape to keep it stuck to the bottom so your print doesn't accidentally come off in the middle of its print. So let's take a look at printing. Let me fast forward. And you see how with due time it prints a rabbit. Now, to a class, I would let this run for the full length, but just speeding through this. So the other type of 3D printer is called a resin 3D printer, in which it's already in a liquid state, and I believe it uses a projector to project the image, and the print bed pulls it up and out, which is really cool. I haven't dealt with these, but they're another really cool 3D printer that exists. So what have people done with it? There's quite a bit. I'm just showing off a little bit of what people have done. So you can do decorations with these. So here are some water bottles, and people printed little vases to, add decorations to the house, maybe some nice things. There are food 3D printers that can print with chocolate and pizza and such. I don't know what they've done with these, if they've been improved. I don't think there's any consumer out right now. I think it was just a concept someone could come up with. Now, speaking of food, when I was talking about earlier about a print coming off the print bed, there's actually a thing called spaghettiing. So here on the left is what it looks like when a print fails, and here on the right is like spaghetti noodles on a printer. Let's see what we got. Dresses. People have printed clothing and fashion statements with 3D printing, which is really cool. Cars. For as much as I know, just the body of the car was 3D printed, and everything else was still needed to be assembled. But it's really cool. And I know there was a guy who printed his daughter castle out of concrete, and there was another company that printed houses on the spot. The concept of printing a house has been around, but if you look at here with the castle, you see the guy, he needed to print it at a different location and then assemble it on site, whereas there was this new concept for a house where the printer prints the house on site, so you don't have to move any parts, which is really cool. And then the biggest one right now gets a lot of traction is prosthetics. If you're missing an arm, we've gotten really good at to the point where we could just print you a new arm. A lot of universities are doing that now. And if you're a little squeamish, you might want to look away. But that is a 3D printed ear with stem cells. And I heard how this ear prints, not prints, you can hear much better than a regular ear. So there's that. And here is a illusion that the print isn't that big. The woman is off to the distance, but there's a printer out there that can print in full color. And to get a picture like this, you use something called a dupe machine, in which there's a room of a bunch of cameras, and it just takes your picture all at once, and it stitches you together. And it's like a half powder 3D printer, half inkjet, which is it's really cool. Not to brag, I did something similar to this where I printed my head, and we held a fundraiser where we printed other people's heads. If you go back to the intro, you'll see a quick little picture of my 3D printed head. But moving on. Iron Man. That's cool. This guy 3D printed his own Iron Man suit. So there's a lot of really cool things you can do with 3D printing. And if you're not interested in making your own things to 3D print, there's websites you can just download things where people make things for free. You can just download it and print it off of a printer. Thingiverse is the most popular one, but there are a lot out there. So here's how to actually design your own thing to 3D print. So there's a thing called C.A.D, which is what I do, called Computer Aided Design. I hope that is self-explanatory, in which you have an environment where you make a shape. So most things that when you want to 3D print something can just be broken down into basic lines, squares, circles, and triangles. So if you look at these shapes right here, you can see how you can break all these things down into their basic shapes. The one I start students off on is called Tinkercad. It is a free CAD software online, and it uses something called Boolean operations. The two top ones out there that I know of are Autodesk Inventor and SolidWorks. I use Autodesk Inventor, and which you can get a free student edition for, and SolidWorks is really, really good too, but I can't get a free student edition of it. So Tinkercad, for the beginners who just want to start off designing basic things, you can just drag shapes in there and form some stuff. So the Boolean operations I was describing is you have a palette of 3D shapes to the right, and you can combine them in such a way that you can get cool, unique shapes that you couldn't otherwise. Whatever. So here's a quick one where I made a house where I dragged a box in and roof, and what I would do is I made house, and then I did a Boolean remove as to remove the material that was right there to say house. And I actually have this 3D printed, which I'll show in a later video. So, okay, how to get your design to the 3D printer. This is just the button pressing part of it. So now that you've learned what they are, how they work, and some basic ways to make your own designs, it's how do you get these 3D models to the 3D printer. So picture this bunny is the thing you made. What you have to do is you have to get it into a STL file. And if nothing else, every single CAD or 3D shaping software out there can convert to STL, which stands for Standard Triangle Language. It's like every currency, the universal currency of all CAD programs. You can import and export as triangles. So this is what it looks like, and when you have your 3D file as just an STL, it is referred to as a mesh of triangles. And so this is what your money looks like. You get your STL into a slicer program. For Ultimaker, the one I use, the slicer program is called Kira. I think Kira can convert so you can print with other 3D printers, and I think there's other slicer programs that can do the same, but the one you typically use for the Ultimaker is Kira, and this is what it's the print preview software of the 3D printing world, where you can see what it's going to look like when you're about to 3D print it. You can see this yellow right here is your prints most of the time are hollow inside. So, when you save through the slicer program, it's saved as something called a G-code. It's just a text document with coordinates on it, and those coordinates tell the machine to where to move. And so the other machine that would use G-code is anything that really uses like stepper motors. As you can see, there's like a stepper motor right here, such as this mill right here, 3D printers, or rather not a mill, but a CNC router, and a robotic arm. A lot of the times use stepper motors. So in the case of the Ultimaker, you have to save your G-code into an SD card and just put it in the printer and press print. So this is everything, the whole enchilada of everything you need to do. So it starts off in some CAD program like Tinkercad, gets exported as an STL, put into Kira or any other slicer program, then exported as a G-code. And some 3D printers can go straight from G-code into the printer. Other times you need an SD card to put into the printer. And so this is all the files I ask my students to save in a USB. And if everything's okay, I'll 3D print the part that they made. So there is everything you need to know about 3D printing from concept to finished product.